this last type of factoring I like to just call factoring completely. Now, a lot of times in problems, they'll tell you always to factor completely, but to me, factoring completely is kind of like a hint, right? It's like a code for, hey, this problem is going to require more than one step, right? And how could it require more than one step? It could be a couple things. You know, you might have a GCF and then an x squared plus bx plus c trinomial, right? You might have a grouping problem and then a difference of two squares, okay? But regardless of what you have, any kind of factoring problem that you have, regardless of whether you think it's an ax squared plus bx plus c, or a difference of squares, or a sum of cubes, whatever you think it might be, or even a grouping, right? Even if there's four terms, the very first thing that you should always look for, and I'm even guilty of not doing this myself sometimes, but if you don't do it, you end up running into problems if there is one. You always look for a GCF as your first step in any factoring problem, because if nothing else, it simplifies the problem, right? It brings the numbers, it cuts down the numbers a little bit, right? And cuts down the exponents a little bit. So the first thing that you should always do, without question, is look for a GCF, okay? So with that in mind, 11 and 12, okay? So 11 is saying x cubed plus 5x squared minus 4x minus 20. Well, is there a GCF? No, because the last term doesn't have an x, and the first term does not have a coefficient, so there's going to be no GCF here. So that's out. Now, it's four terms, so the only method that we had for things involving four terms was grouping. Okay, so let's try grouping here. So we'll look at the first two terms and the second two terms separately. So in the first two terms, I can take out an x squared, and then what's left when I take out an x squared from the first two terms? Well, an x and a plus 5. Okay? So that's factoring the first two terms, and now when I factor the second two terms, I can take out a negative 4, and again, whenever the third term is negative, I want to take out a negative, whatever my GCF is. So negative 4, and then when you take that out, you have x, and then negative 20 divided by negative 4, which is positive 5. So it worked, because now you have a GCF of x plus 5, but you're left with x squared minus 4. But again, remember, factor completely is hint for more than one step. I only did one step there, right? I only did my grouping. So chances are one of these things is also going to factor. Now x plus 5 can't factor anymore, so just bring that one down. But x squared minus 4, yes, it does factor, because x squared minus 4 is actually a difference of squares, right? This is a squared minus b squared, and it's going to factor into a minus b times a plus b, where a is x and b is 2. Right? You're basically just taking the square root. Square root of x squared is x, square root of 4 is 2. Put a minus sign between this one, and then put a plus sign between those ones. So that would be your factored form. X plus 5 times x minus 2 times x plus 2. And these would be a little bit more work if you were going to multiply them out to check them, but you can still do it, right? Right? You would probably multiply the x minus 2 times the x plus 2 first, and then multiply that by x plus 5, just to make sure it works. It works out. Okay? So that's one example of factoring completely. Okay? Now, second one. Second one is only 3 terms, so you might look at it and you say, oh, it's an ax squared plus bx plus c, but it's not, because it has a cube. So that brings you to, all right, well, is it a GCF? Is there a GCF here? Yeah, there is. Right? And remember, that was the first thing that we should have looked for. Right? I shouldn't have talked about ax squared plus bx plus c. I should have first said, is there a GCF? So what's the biggest number that will go into 8, 28, and 16? Well, 8 will go into 8 and 16, but not 28. 4 will go into 8, 16, and 28. So it's 4. And then x cubed, x squared, and x. Remember, I can always take out the lowest power for my GCF. So I take out an x to the first. And now see what's left. So when I take out a 4x, I'm going to be left with 2x squared plus 7x minus 4. And now, there shouldn't be a GCF, which there isn't. So this looks like it's just going to be an ax squared plus bx plus c. Right? So I bring my 4x down. And this one, I guess I would probably do by guess and check, maybe. I mean, you could use AC method, but I'm really doing guess and check because I don't have enough room here. But you could do AC method, right? So how am I going to get 2x squared? It's got to be 2x times x. All right? And how am I going to get negative 4? Well, there's two possibilities. It could be a negative 2 and a positive 2, a negative 4 and a positive 1, or a positive 4 and a negative 1. But now here's the key. Since my middle term is so big, it's 7, that means I somehow have to have either the outer or the inner get pretty big. And how am I going to make the outer or the inner get pretty big? If I multiply 2x by positive 4. Because then that's a positive 8x, and then all I need to balance it out is a negative 1x that I now have with the inner term. Right? So I have 4x times 2x minus 1 times x plus 4. And that'll actually work, because again, you can see if you do the outer and the inner as a check, that's 8x. The outer is 8x, the inner is negative 1x, so that adds up to 7x. So that was correct. So here's my factored form. All right? And again, factor completely, chances are it's code, at least on my tests and stuff it is, for, hey, this problem is going to be multiple steps. So make sure that you don't just stop after you do one. All right? So keep that in mind for my quizzes and tests. Factor completely means more than one step.